We have built our firm around one idea: to lead our clients from where they are to where they want to be. But the ability to deliver the leadership and service our clients deserve doesn't happen by chance. It's a product of who we are. We are engaged, diverse, and innovative thinkers who go above and beyond what is expected because we know our efforts will carry us to achievements others never thought possible. We are unafraid to take the necessary risks that lead to new successes. We embrace change because we know sound principles will guide us through new opportunities. We are committed to empowering our people, our clients, and our communities to become every part of what they aspire to be. We are persistent on our journey forward. It is our openness to collaboration, our desire to achieve better, our character, our vision, and most of all, our people that make us who we are. That's the HB difference. We are Husch Blackwell.
Hello, everyone. I am David Hertel, a partner in Husch Blackwell's Safety and Health Practice. Before we begin, I would like to cover a few housekeeping items. At the bottom of your audience console, there are multiple application icons for your use during the program today. If you have questions during the webcast, please submit them via the question box. We will try to answer questions during the webcast today, but if a fuller answer is needed or we don't have time, it will be answered later via email. A PDF of the presentation is available in the resources folder. This program has been approved for legal education hours. To report your hours, click on the CEU icon at the bottom of the screen. A certificate of attendance, including course numbers, will be mailed to you tomorrow along with a recording of the webcast for watching and sharing. Towards the end of the program, be sure to complete our short survey. We use your feedback to plan future programs that are applicable to your business needs. That is all for the housekeeping items. Let's get started with our program. We'll be talking with you today about combustible dust in the workplace and the regulations and technical issues employers face. Joining me today is Dr. Brent Cox, Managing Engineer of Thermal Sciences at Exponent. Dr. Cox specializes in the investigation, analysis, and prevention of incidents involving fires, explosions, and chemical releases. He has helped clients solve technical challenges associated with potentially flammable and/or reactive materials in the chemical process industry, agricultural and agro-industrial facilities, mining and metal processing, pulp and paper manufacturing, hazardous waste treatment and disposal facilities, and consumer products. For an overview, we're basically dividing the program up into three parts. Initially, Brent is going to discuss with you what is a combustible dust and what are some of the workplaces in which it is found. Then I'm going to talk on some of the legal requirements employers face when they have combustible dust in the workplace. And then Brent will be discussing some relevant technical considerations relating to combustible dust in the workplace. Brent, do you want to take it from here?
Sure. Thanks, David. And thank you all for joining us. Before we go any further, I wanted to put up the definition of combustible dust. Like most technical jargon, combustible dust is a combination of words that, when put together, mean something very specific. And for this definition, we're referencing the National Fire Protection Association standard on the fundamentals of combustible dust, NFPA 652, which we'll touch back on a few times as we're talking today. But the way they define combustible dust is a finely divided combustible particulate solid that represents a flash fire hazard or explosion hazard when suspended in air or in the process-specific oxidizing medium over a range of concentration. So that's sort of a mouthful, and let's take it in parts, starting with the first part. So a finely divided material, what does that mean? Well, NFPA 652 gives a rule of thumb about 500 microns, below which a material will probably constitute a dust. So think table salt, except table salt's doesn't fit the rest of the definition, meaning that it's not combustible. So what is a combustible particulate solid that presents a flash fire hazard or explosion hazard? Well, we'll get there as we move through this presentation. So where might you find a dust that may be combustible? So combustible dust is present across a broad spectrum of industries. I suspect most of you are here because you already know that your industry may have combustible dust. I think most stakeholders are generally aware of the hazards now, but we still find facilities that are surprised by aspects of the hazard or aspects of the regulations. And there are also industries that live on the margins in some ways. The one that comes to mind, plastics and some textile aspects where combustible dust may or may not be present depending on the specific kinds of equipment and processes. And process changes may take you in or out of consideration. So let's talk a little bit more about the dust themselves. Here is a selection of material that may merit closer consideration. One thing I'd highlight is depending on your material, it may be your product or your raw material that's a combustible dust, or it may be the waste from your material, the dust that comes off of corn, for example. And there's a lot of those examples in the agricultural and food space, but then also in the other industries listed here, as well as many others, I'm sure. So one thing that's also important to think about when thinking about combustible dust is when you think about liquids and gases, it's pretty straightforward to determine what material presents what kind of hazard. A fire explosion hazard is usually just takes going to the SDS to figure out. But for the ignitability and the susceptibility of dust, it can be much more sensitive to circumstances. So you really need to think about the specific context. So before we go any further, we'd like to pose a poll question to everyone. This was touched on a previous slide, but which choice most accurately identifies a combustible dust as defined by the National Fire Protection Association? A solid particle that will burn, solid particles that can be suspended in air, or a finely divided combustible particulate solid that presents a flash fire hazard or explosion hazard when suspended in the air or the process-specific oxidizing medium over a range of concentrations. I'll give you just a few more seconds to answer that question. Hopefully everyone has answered. Yes, and you were partially correct, those of you that said solid particles that can be suspended in air. That's certainly dust, and that's something worthy of more consideration. But in order to be the combustible dust that we're talking about, it must also present this flash fire or explosion hazard when suspended in air or some other oxidizer. So thank you for your participation there. So the last slide before I hand it back to Dave for a little while. As I said, the fire and explosion hazards associated with the dust are very scenario specific. So it's helpful to have a specific process in mind when thinking about if and where hazards may be present. Here we've created a hypothetical process that has some equipment used across a broad swath of industries that handle powders and bulk solids. In this toy scenario, we take some raw material and we send it through a grinding mill. From there, it's pneumatically conveyed to a cyclone where the coarse material is separated from the finer material. The fines go into a bag house where they're further separated from air, which is discharged elsewhere, and those fines are collected as waste. Now, I've left a lot of details out that could or could not be included in this situation. I don't have where the walls are in this building or whether there's any venting, but nonetheless, think a little bit about this scenario and how its circumstances change each step along the way, and we'll go through this in more detail. And in the meantime, I'll pass it back to Dave.
Thanks, Brent. OSHA has a combustible dust national emphasis program, which puts an emphasis on inspecting workplaces that create or handle combustible dust. The program sets forth OSHA's policies and procedures for inspecting such workplaces. OSHA does not have a comprehensive rule covering combustible dust. On the slide are some of the provisions of the Occupational Safety and Health Act and implementing standards that OSHA relies on in issuing citations against employers for combustible dust hazards in the workplace. I'm going to address the General Duty Clause and a couple of other standards listed, which OSHA frequently relies on to cite employers with respect to combustible dust hazards. I should note that to the extent OSHA has a somewhat detailed, comprehensive combustible dust standard, it would be the grain handling facility standards referenced on the screen. However, that only applies to grain handling facilities. Also, note this list is by no means all-inclusive. There are various provisions of OSHA standards which OSHA may rely on to cite an employer with respect to conditions relating to the presence of combustible dust in the workplace. The last bullet point there on the screen just mentions some of them, dealing with exit routes, emergency action plans, fire prevention plans. OSHA will not hesitate to cite in those areas too when they're investigating combustible dust hazards. It's important to remember that the Occupational Safety and Health Act allows individual states to opt out of the federal regulatory scheme, and that they have their own, and they can have their own OSHA-approved state plans for regulating health and safety in workplaces. Many states have opted out of the federal scheme. The health and safety standards in states with OSHA-approved state plans may be different than what exists under OSHA. However, as a practical matter, in many respects, the safety and health standards are usually very similar, if not the same. Many of these states take the same approach to combustible dust as OSHA, but, for example, California has a specific code addressing combustible dust. OSHA often relies on Section 5 of the Occupational Safety and Health Act for citing employers for deflagration, explosion, and fire hazards caused by combustible dust within processing systems, such as dust collection systems, vessels, containers, equipment, and ductwork. This is called the General Duty Clause. The General Duty Clause is a catch-all provision that applies when no specific safety or health standard promulgated, when there's no specific safety and health standard promulgated under the Act, governing the specific hazard at issue. To establish a violation of the General Duty Clause, OSHA must show a condition or activity in the workplace presents a hazard, the condition or activity is recognized as a hazard, the hazard is likely to cause death or serious physical harm, and a feasible means exists to eliminate or materially reduce the hazard. There's lots of decisions by the Occupational Safety and Health Review Commission as well as the courts over the proper interpretation and application of the above elements. Unfortunately, in this 1-hour webinar, we don't have time to delve into those. As I mentioned before, to prove a violation of the General Duty Clause, OSHA must prove that a condition or activity in the workplace presents a hazard. With respect to combustible dust, OSHA must establish that the employer is generating, using, or handling the combustible dust in a manner which creates an unsafe condition which may injure employees. The mere fact that OSHA establishes that the employer is generating, using, or processing combustible dust does not establish a hazard. Generally speaking, OSHA must establish that a condition or process exists which gives rise to a credible risk that an explosion or fire could occur which would injure employees. As Brent is going to explain in further detail in a few minutes, whether there is a hazard will depend on the type of dust, particle size of the dust, the concentration of the dust within the process system equipment, the existence of ignition sources and the nature of those sources in relationship to the specific dust involved, and the strength of vessels, containers, and ductwork in the plant. If the right conditions do not exist in the workplace, even though there is combustible dust, there is not necessarily any risk of an explosion or fire which could cause injury. OSHA must establish that the unsafe condition that they cite an employer for is recognized as a hazard. In effect, OSHA must show that the employer was on notice that the condition cited was unsafe. OSHA can do that in one of two ways, either by showing that the condition was actually recognized as a hazard by the employer, by that particular employer, or that the condition was recognized within the employer's industry as being unsafe. Thus, for example, if OSHA cites an employer for violating the general duty clause for failing to vent a baghouse or failing to have a dust collector outside, it must, among other things, be able to prove that either the employer recognized that as a hazard or the condition was recognized by the employer's industry as a hazard. On the screen are some examples of the types of evidence OSHA uses to establish that an employer had actual knowledge of that particular condition existing at its plant was unsafe. One of the types of documents that OSHA likes to use are the reports prepared by auditors for workers' compensation insurance carriers and property and liability insurance carriers. Frequently, those reports will reference to what the auditor, who usually is not particularly experienced in the area of combustible dust, considers to be potential hazards with respect to combustible dust in the employer's workplace. It's important that employers do not leave these reports unaddressed. You either should further investigate and establish and document that the carrier's conclusions are wrong, and possibly have the carriers correct or supplement the report about a potential dust hazard, or you make appropriate revisions in your facilities or operations to eliminate the hazard. Again, those types of reports are typically used against employers by OSHA in litigation. An analysis should be undertaken and well documented. Also, you will see a reference to OSHA hazard alert letters. Those are letters OSHA will at times issue after an inspection when it has decided not to cite an employer for a combustible dust hazard. It puts the employer on notice of that OSHA believes there may be hazards at a facility, even though OSHA has decided for various reasons not to issue a citation. Those letters should not simply be thrown into a drawer and left unaddressed by the employer. The employer should address those. This slide sets forth the types of evidence OSHA will rely on to attempt to prove that a condition or practice at an employer's facility relating to combustible dust is recognized as a hazard in the employer's industry. The only one I would like to single out is the voluntary consensus standards issued by private organizations, such as the National Fire Protection Agency. Those are voluntary standards, unless they're, for example, have been adopted by some state or local fire or building commission or specifically incorporated into a safety or health standard. However, in most general duty clause citations involving alleged combustible dust, fire, and explosion hazards, OSHA will use them, those voluntary standards, to establish the particular processes or equipment an employer has in its plant relating to the handling of combustible dust do not comply with NFPA standards, and thereby OSHA will attempt to establish the process or equipment is recognized in the employer's industry as being unsafe. To the extent that an employer has combustible dust in its facilities, it would be best practices for the employer to comply with NFPA standards relating to combustible dust that are applicable to the employer's industry. Not only is that a good safety practice, but it will go a long way to avoiding OSHA citations and increasing an employer's chances of defeating an OSHA General Duty Clause citation if one were to arise. Up on the screen now are just some examples of the NFPA standards that OSHA will frequently rely upon or cite in a citation involving combustible dust hazards associated with an employer's processing system or manufacturing operation. OSHA must prove that a cited condition would create a significant risk of death or serious injury to individuals. Typically, with respect to combustible dust, if there is a risk that a condition could lead to an explosion or fire, this element is proved. However, if an employer can establish that a hazard would only lead to property damage and not injury to individuals, this element would not be satisfied by OSHA. Thus, for example, if an employer can show that an explosion or fire would be safely contained within the vessels, containers, and ductwork of the processing system, and only damage to equipment would result and not injury to an employee, then there would arguably be no General Duty Clause violation. And finally, as far as for elements under the General Duty Clause, OSHA needs to establish that there is a feasible means to abate or mitigate the hazard. Citations for violations of OSHA General Housekeeping Standard may be issued if surface dust accumulations outside of dust collector systems or other vessels, equipment, and processing systems can create an explosion, deflagration, or fire hazard. Courts in the Occupational Safety and Health Review Commission have held that the standard applies to the hazards of combustible dust. The final bullet point there also is guidance, again, an NFPA standard which OSHA looks to determine whether there are unacceptable levels of dust, combustible dust. Like the General Housekeeping Standard, OSHA may use Standard 1910.176 to cite excess accumulations of combustible dust in storage areas. Standard 1910.307 and 1910.399 typically come into play where, as a result of the employer's production processes, there is combustible dust accumulating or could accumulate on electrical equipment in various areas of the facility. For example, this can arise in the packaging areas of dairy powder production facilities, or in areas where combustible dust escapes from parts of the processing system and has the potential to accumulate on surrounding electrical equipment. Under Section 1910.399, Class 2 locations are areas where combustible dust may be present in various hazardous concentrations. Class 2 locations are divided into two divisions, Division 1 and Division 2. Division 2 locations are, very generally speaking, areas where combustible dust is in the air not sufficient to create an explosion hazard, but sufficient to cause accumulations of dust on electrical equipment. An employer is required to classify the areas of its plant and only allow for the use of equipment which has been approved for use in the classification location in which it is being used. Note, however, that under Section 307C and C3, even though particular equipment has not been approved for use in the location in question, the employer can still attempt to demonstrate that the equipment will provide protection from the hazards arising from the combustibility and flammability of the dust involved, and thereby not be deemed to have violated the standard. Typically in situations where a piece of equipment has not been approved for the classified location in question, is cited by OSHA, but the employer believes that it is otherwise safe for use in such location, an expert or consultant, such as somebody like Brent, would be retained to see if he could render an opinion that use of such equipment is safe under the particular situation involved. Again, considering the particular dust involved, the ignition sources, the ignitability of the dust, and so forth, and the design and construction of the piece of equipment at issue. I should also note, and not mentioned on the screen, there is another section of these standards, it's 307E, which establishes a special lower standard for what's known as general purpose equipment. And that's when if fans are brought in that could be bought from hardware stores or other equipment from hardware stores, that kind of thing, a general use equipment. If OSHA were to cite you, you may be able to find a defense under this section, which has, it's not an exemption, but it sets up a lower standard for general purpose equipment. The hazard communication standard, which most people are familiar with and is applicable to most employers, defines hazardous chemical, and hazardous chemical is defined to include combustible dust. As a result, employers that have combustible dust in the facilities have to provide information and training on combustible dust to employees. As I mentioned before, OSHA typically uses NFPA standards to show that a particular condition or process existing within an employer's plant is recognized as a combustible dust hazard. What is important to understand is that most of the NFPA standards that OSHA will rely on provide that one can comply with the NFPA standard either by complying with the specific rules set forth in the standard or complying with what is known as the performance-based approach. These standards, these NFPA standards, typically set forth specific rules or requirements that should be followed with respect to what must be done by way of a process or equipment that is handling combustible dust in order for the process or equipment to be safe. OSHA will usually reference in its citation one or more of these prescriptive rules in support of its position that a condition existing at the plant is recognized as unsafe. However, those NFPA standards state that you don't necessarily have to comply with the prescriptive rules to comply with the standard, but rather you can comply with the standard using what is known as the performance-based approach. The performance-based approach, very generally speaking, means that if one can show the process or equipment being used achieves the overall safety objectives and goals of the NFPA standards in question, those are usually in the early part of each standard, then one will be deemed to have complied with such NFPA standard, even though it may have violated the prescriptive rules. Again, this is a situation where an expert may typically be retained to establish that under the performance-based approach, the employer is complying with the applicable NFPA standard, even though OSHA believes that you've violated a specific prescriptive rule. It doesn't matter if we comply with a performance-based approach. For example, an NFPA standard might say that a rotary valve must be of a particular design to serve as an isolation device with respect to explosions and deflagration. However, an employer in the dairy industry might prove that such design is not workable in the dairy powder industry, as the rotary valve would become clogged by the powder, and that an alternative design, which is used by the employer, would still effectively stop a deflagration from progressing downstream from the rotary valve, in which case that would offer a defense. In addition, in each of these NFPA standards, there is what's known as an equivalency provision. So if you're able to show that what you're doing is essentially equivalent as far as for the various items shown on the screen, even though it's not what's specifically prescribed in the rules, then you are still in compliance with the standard. Finally, I just want to mention that an employer who has combustible dust within its facilities, it is a good idea to conduct a dust hazard analysis to help ensure that the employer is safely handling and using such dust so as to avoid an explosion of fire. Also, NFPA 652, which again is only a voluntary standard, provides that a dust hazard analysis should be performed for facilities where combustible or explosible materials are present. DHAs are to be reviewed and updated at least every 5 years. Finally, since we're getting very close to the date, it should be noted that when the NFPA was originally made effective, which was on NFPA 652, was originally made effective September 7th, 2015, it provided that then existing processes and facility compartments for facilities essentially that existed as of September 7th, 2015, they had until September 7th, 2018 to do the DHAs. That deadline was extended to September 7th, 2020. Dust hazard analysis under NFPA 652 are to provide for the evaluation of fire, deflagration, and explosion hazards, and provide recommendations to manage those hazards. Typically in DHAs, you will find addressed many of these things Brent will be talking to you about. Dust explosion characteristics, airborne dust concentrations, potential ignition sources, isolation, containment, explosion suppression, and venting systems, and what additional safeguards are needed. Again, a big part of those DHAs is to identify potential hazards relating to combustible dust. With respect to factors that you should consider before you arrange for a DHA, well, there's a few of them. Obviously, one is cost, and cost is important, but it should not be the overriding concern. Second, probably more important, is the qualification of the expert or consultant that's going to be doing the DHA. They're not all the same, and they don't all have the same specialties. An employer wants an expert or a consultant that is experienced in their particular industry and also experienced with respect to the particular type of operations that the employer has, because they can make a big difference. I've had situations where an employer, a client, has retained an expert and came back suggesting that various steps had to be taken, totaling costs of over $250,000 just to do. Another expert came in and said, no, you don't need to do that. You can make it just as safe. If you consider all the factors, it'll be just as safe by spending as little as $10,000. So you need to take care in doing that. And then finally, an employer should decide whether to have the expert or consultant retained by outside legal counsel to possibly establish a basis for not having to disclose the report to OSHA in the event of litigation based on the attorney-client privilege or what is known as the work product privilege. Further, an attorney experienced with combustible dust and their hazards can also help appropriately guide and direct the efforts of the expert or consultant. Brent, I'll turn it over to you at this point.
Great, thanks, Dave. So first, let's take another poll question. So does NFPA 652, the standard on the fundamentals of combustible dust, provide that dust hazard analyses are to be performed? Yes or no? I'll give you about 10 seconds to answer that question. Okay, thank you very much. Easy answer, thank you all. Okay, so Dave talked a lot about hazards, so I thought I would drill down a little more on the specifics of the hazards that we're talking about here. The first of which is combustibility or flammability, and the other is explosibility or explosion hazard. So to manage the hazard, first we have to understand what it takes for that outcome to manifest, or stated differently, what ingredients do we need to keep apart to prevent the hazard from being realized. The concept of the fire triangle is useful in this regard. For a fire to occur, three things must be present. There must be a fuel, your material must be capable of ignition, there must be a competent ignition source, which is to say a source capable of igniting your specific fuel, and an oxidizer must be present, which is usually air, but it doesn't have to be. Finally, there must be a situation in which these three factors come together into a viable ignition scenario. The last part is usually not included, but is an important factor. As an analogy, most of you are probably on board, but think about your car. For a gasoline-fueled car, you need gas, you need air intake, you need a spark plug, and you need the timing to be right. So the spark plug ignites when that fuel-air mixture is present. So the explosion hazard is similar in nature, but there's a few additional ingredients that you have to have. First, we're talking about dust here. The dust must be suspended in air at a concentration capable of supporting an explosion. Were this mixture to ignite in free space, a flash fire may occur. However, if the mixture is physically confined within a container, the pressure in that container may rise and the container may ultimately fail, and that release of elevated pressure is what we call an explosion. So for that explosion to happen, you need some sort of confinement to allow that overpressure scenario to develop. So thinking about the gasoline again, a pool of gasoline can support a fire, but you need that engine cycle to be timed right so that the fuel-air mixture is pushing that piston with its overpressure. That's a little explosion. Sort of. So now let's take a look at each of these legs of the pentagon and under what circumstances, when and where each of these components may exist. So the foundation here is the fuel. Dust cannot participate in a fire explosion. It does not present a fire explosion hazard. So let me state that again. If the dust cannot participate in a fire explosion, it does not present a fire or explosion hazard. So how do we tell? Well, gases and liquids, as I said earlier, you can usually look up the SDS and figure out the flash point, the flammability limits, and determine if your process is in that window. I go the long way towards understanding the circumstances where those materials can serve as a fuel. However, with dust, SDS usually doesn't provide that much information. It may identify the potential for a fire explosion, but the circumstances are usually less well defined. In other circumstances, the material may not be considered a dust that you received, but due to some processing or something else, combustible dust may form. So in these situations, and probably most situations, some testing is necessary to understand when your material may be a combustible dust. So there's a variety of places where you can have these tests done. From my work for Exponent has a dust testing lab in the Boston area that we use company-wide. But the first question that you're asking of your material during a test is usually how much and how fine is it? So what does the particle size and morphology look like? This can be as simple as just taking a stack of sieves and shaking the mixture for a while and letting it divide up into size, or it can be done through laser, using equipments, using analytical tools that use laser particle size measurement. It's prudent to understand the particle size of all samples that are tested, because you may later need to compare samples of the same material collected from another location, which may perform differently in the subsequent tests. For example, if you're taking it from a stock versus a raw product bin. So once you've determined the size, then you need to know, is the material combustible or explosible? So skipping over combustible for just a second, is the dust explosible? The way you determine that is usually a test called the go-no-go test, where a variety of concentrations are ignited in a test chamber and instrumentation watches for a pressure rise. If the material is deemed explosible, it's usually also considered combustible, but there's also a standalone combustibility test. So if it's not considered explosible, you may need to do that combustibility test. There's not a standard flash fire screening test, although many have developed, including Exponent, have developed their own internal flash fire screening tests because it's been found that some material that is determined to be explosible due to the no-go test will not ignite in a flash fire even through an oxyacetylene torch, probably due to the igniter during the explosibility test. So if a material is not combustible or explosible, it likely will not present combustibility or explosibility hazards. So you're probably done, at least with that material. But if it is explosible or combustible, you'll need to figure out under what conditions that hazard may manifest. So that's when you need to do a little bit more testing. As I described earlier, with a flammable liquid or a flammable vapor, you can usually go to the SDS and figure out what is the flash point or what are the what's the lower and upper flammability limit. For dust, there's a similar, although not exactly the same concept called the minimum explosible concentration. Here, the word maximum doesn't belong there. So what range of concentrations might the dust be explosible in? And that can be compared back to your process. What range of concentrations are relative to your process? And we'll talk about that a little bit later, but how much dust per unit time versus how much air per unit time, which then gives you a concentration. Now, MEC can vary significantly depending on the size of the material, the humidity of the material, or moisture content of the material, and the test method. So I just took a few examples here to show corn, depending on the size of the specific sample. You may see the MEC go up or down. Similarly, magnesium, you go down in size, you go down in MEC. Corn, you go down in size, you go up in MEC. And there's also variation in the test method. So that's certainly not a rule to be used, and it's usually recommended that you test your specific material. When you're collecting your material, it's important to consider what samples represent the specific area you're analyzing, and think about what and where and how much material you may need to collect from those areas. Certain tests require more material than other tests, and if you have a process that doesn't generate a lot of dust, well, first, good for you, but second, it may be hard to get enough dust to do some of this testing, and so you may need to plan sometime in advance if you're just collecting material. Now, material can be prepared on site. It can be ground or it can be sieved to just separate out the fines. But again, you need to think about why you're doing that and what you're testing. Many labs will recommend that a sample be sieved through a 200 mesh, so all the material tested is 75 microns or less. That's really good for understanding worst case scenarios, but may or may not have the value you're looking for. Other aspects, do you want your sample dried, or is there a specific moisture content that's relevant in your process? And then there's other ignition susceptibility tests, such as minimum ignition energy, minimum ignition temperature, and electrical properties, and then self-heating for some materials that are susceptible to self-heating. So once you've figured out, can your material burn, and you've covered suspension in the process of measuring your MEC, the next question is there a viable ignition source? So this may be foreign material, This may be hot work, hot surfaces, electrostatics. They're all things to think about. But depending on the dust and the equipment, there's a different set of evaluation or different tests you may need to consider when probing this question. Oxidizer, this is usually air, but some processes rely on nitrogen or another inerting agent to manage the dust explosion hazard. And if you're in that category, you may need to pay particular attention to points of air ingress, such as vacuum relief vents, or steps in your process like raw material addition, or startup and shutdown, and process upsets or maintenance activities that may permit air to enter into your system. And lastly, close to lastly, if the fire triangle exists inside confinement, what kind of overpressures might be experienced? Can the containment withstand that explosion event without injuring employees, or will it vent to a safe location? And what might happen to interconnected equipment if the deflagration can propagate elsewhere? The last one is a much harder question to answer often, but there's some guidance in that regard. And finally, as I mentioned before, all this has to come together in space and time into a viable ignition scenario. Think back to the inerting scenario. If during certain phases of operation you do have air that can make it into your process, can you do other things to take away other legs during that step so that they're not present in the same time, albeit in the same place? So just to reiterate here, the different types of hazards, the flash fire hazard that I stuck here in the middle, you just remove confinement from explosion. But as we're thinking through our hypothetical milling process, we want to think about those hazards. So before I go any further, we have another poll question. According to NFPA 652, which conditions are required for a dust explosion to occur? And there are 4 options here. A combustible dust suspended in an atmosphere able to support combustion at a concentration greater than the minimum explosible concentration, confinement of the dust cloud by an enclosure or partial enclosure, an ignition source of adequate energy or temperature to ignite the dust cloud, or all of the above. I'll give you another about 10 seconds to answer that. Thank you all. Again, an ignition source is necessary, but all of them have to come together for that dust explosion to occur. So back to our hypothetical milling process, and I reiterated again these hazard triangle, hazard polygons, but we're going to focus as we're talking through these next slides on just the explosion hazard for simplicity. So our first step is to look at the fuel air suspension within the equipment. Keep in mind this will likely change as you move throughout the process. You may need to consider transient events depending on your kind of equipment, such as a bag house. Is it a pulsed air bag house? But as you look through, if you had X-ray glasses and could look through the side of this pipe, as you move through the pieces of equipment, you would notice the material within the product stream is changing in shape and size and distribution. So because explosibility depends on material size, as you grind, separate the material, the MEC also changes because the particle size is changing. So one strategy is to start at the finest and work back. If you find this material is explosible per the go no-go test, then you might need to consider the next leg up. If you don't, then there's a chance you can stop there. So what about ignition sources and ignition scenarios? Well, the type of potential ignition sources you have in the system will dictate testing and vice versa. Static electricity may be adequately managed by bonding and grounding if your minimum ignition energy is sufficiently high for your material, but if it's too low, you may need to consider other protective measures due to the risk of electrostatic ignition. I'm sure you can all see in the middle of the screen, there's a grinding mill. Grinders and other size reduction equipment are often given considerable attention during this evaluation process. How are you managing potential ignition due to tramp metal or frictional heating and circumstances such as that? It may take more tests to specifically understand the sensitivity of your material to high temperatures, to mechanical sparks, or other ignition mechanisms that could be introduced by grinding mill or other size reduction equipment. Containment or venting. So if you have an explosion, what kind of pressures might you expect? We talked a little bit earlier about explosion severity tests. Those usually produce a maximum pressure and then a measure of the maximum rate of pressure rise. That's the kind of information you need to perform this kind of evaluation, and will also inform what kind of protective measures, such as containment, venting, or suppression that may need to be considered. You also will, at this step, particularly if considering containment or venting, need to think about what kind of equipment you have. You'll need more detailed information about your equipment specifications. Process geometry may also be relevant. And so I've spoken a lot about hazards, but I've only made passing reference to safeguards like explosion venting. And to that end, I wanted to at least touch on what you might do with all of this information. Of course, not all hazards can be avoided or eliminated. The remaining hazards are generally managed through a variety of methods, either controls or safeguards, call them what you will. But if they're independent safeguards, they can provide an independent layer of protection against a potentially hazardous outcome. Of course, no safeguard is perfect, so there's this Swiss cheese model that is often referred to where a potential outcome manages to make it past one independent layer of protection. Will it make it past separate independent layers of protection and ultimately realize a hazardous event? Obviously, the more independent layers of protection you have, the less likely it is to line up these holes. And as Dave mentioned, after you go through a dust hazard analysis activity, you may end up with recommendations for additional safeguards or protective measures to consider. And when selecting these safeguards, there is a preferred hierarchy. Of course, there's lots of other considerations that go into selecting protective measures, but the hierarchy of controls, which at the first step you would eliminate the hazard. You would then, if you can't eliminate the hazard, substitute it with a less hazardous material, and absent that, implement engineering controls such as temperature sensors or other things. And barring that, you go into administrative controls like don't bump the leg, and then past that you go to PPE, which is the last line of defense. It doesn't make it not important, but you don't want to be testing people's personal protective equipment if you can prevent the event higher up along the chain. So with that, just in summary, the key technical messages that I would like to convey is, if you need to do the work ahead of time to determine, do you have a combustible dust hazard in your process or processes, that it can vary widely and it might not be as simple as just a Google search. And then if you identify that you may have a hazard, determining where they are and where they're not in your process, so that you have this information before somebody asks you about it. As David alluded to, there are deadlines approaching for dust hazard analysis. Not sure what the given current circumstances will do to influence that, but prepare it. But you need to know that to prepare for DHA, you may need to collect a lot of information and have testing done that can take more time and energy than the actual process of doing the dust hazard analysis. So be proactive about that activity. And when you're thinking about how to manage these hazards, think about inherently safer concepts and the hierarchy of controls before selecting a final resolution. And with that, I'll hand it back over to Dave if there's anything else to add.
We have Brent. We have just a few minutes, so maybe it might be helpful just walking through. Again, not saying that OSHA would be correct, but if this is what OSHA is confronting, this process that's on the screen now, they're going to come in and they're going to question the blower, just as Brent said. Is that assuming maybe that's an ignition source? Does it meet the requisite specifications? From the standpoint of the cyclone, if you look at the bottom of the cyclone, it leads down to the larger, goes down to the product. That's likely down in an employee areas. In other words, below the blue cyclone, there are likely an area where employees go to pick up that product or something. OSHA will say, well, why don't you have an isolation if there were an explosion in the cyclone, isolating it so that the employees couldn't get injured. And then OSHA may come in and said you don't have an isolation. If you did have an isolation that higher upstream, either from the cyclone or higher, and you had the deflagration coming down towards the bag house, why did you not have some form of isolation, explosion suppression devices or something else to isolate and protect the bag house? Obviously, OSHA would be looking and saying, well, is the bag house vented, or does it have some other explosion suppression device on it? Again, with respect to under the bag house, again, materials dropping down in that waste cycle area. Likely that's an area where employees are. They may be looking for seeing whether there is isolation there, which could be as simple as potentially a rotary valve at the bottom of that bag house. But those are some of the things they'd be looking at. Again, if you look at blower number 2, they're going to say, well, that may be a hazard if it's not a proper specifications. Well, simply because OSHA makes those assertions or looks at those, that doesn't necessarily mean that there's a hazard for all of the reasons that Brent was talking about. You have to go through the system. You may find that given your product, given your particular dust, the grinding mill is not going to generate enough of an ignition source. And otherwise in here there's an argument that there isn't somewhere after the grinding mill that's going to generate an ignition source. And then as Brent said, just looking at the concentration levels, what is the minimal explosion, looking at the minimal explosion concentration for your particular product, what is the concentration of the dust after, say, for example, it leaves blower number 1? And if that's below the minimal explosion concentration level for the dust, and that remains true throughout the rest of the process, then you may not have a hazard. Of course, you got to look at little things like in bag houses. If the bags pulse, you might have for a period of time, a short period of time, where in the bag house there would be concentration above the minimal explosion concentration. Brent, do you have anything further on those points?
I'd just like to address one comment from the audience that we neglected to mention. Thank you for pointing it out. The comment is 652 has September 7, 2020 as your deadline, but NFPA 61, if you are in the food and ag industry, it provides a retroactivity deadline of January 1, 2022. So just wanted to relay that. Thank you to the audience member that made that point.
That concludes our program. Thank you for joining us today. We hope the information was helpful to you and your organization. As a reminder, this program has been approved for legal education hours. To report your hours, click on the CEU icon at the bottom of the screen. A certificate of attendance, including course numbers, will be emailed to you tomorrow, along with a recording of the webcast for watching and sharing. Be sure to complete our short survey. We use your feedback to plan future programs that are applicable to your business needs. This concludes our webinar. Thank you.